Hello chemistry students, this is now the second video focusing on dot points 1.1.1 and 3. I think I said that right. Let me say that again, 1.1.1 and 3. We're looking at physical and chemical properties in this video. So similar to the physical and chemical changes, but I guess when we're looking at properties, we're more so looking at the characteristics and features that make the substances what they are. And we can look at that from a physical and a chemical perspective. Now, if we're looking at physical properties, we're looking at the properties of the substance itself. Is it, for example, magnetic? What are the size of the particles? Now, they can also be changed by physical processes like cutting and breaking and crushing. What is the solubility of the substance? How much can it dissolve into, say, water or another liquid? Is it soluble at all? Can it dissolve at all? Some things are insoluble. We also have miscibility. So for liquids, a physical property may be its ability to dissolve into other liquids and form homogeneous mixtures. We also have melting and boiling points, the temperature at which things melt and boil. We also have density. Now these two in a second I'm going to be looking at in a lot greater detail. So first off, we have melting and boiling points. Now, every single substance has a different melting or boiling point. So for example, water melts at 0 degrees Celsius, hydrogen melts, so turns from a solid to a liquid at negative 259 degrees Celsius. Sodium chloride melts at very high temperatures at 801 degrees Celsius, and oxygen goes from a solid to a liquid at negative 218 degrees Celsius. Now, I'm hoping that you can appreciate that at room temperature at about 25 degrees, water will have definitely melted and become a liquid. Hydrogen definitely is not a solid. It would either be a liquid or a gas. We'll look at that in a minute with boiling points. Sodium chloride is definitely a solid. It is nowhere near hot enough to melt and turn into a liquid. And oxygen, same thing as hydrogen. It's definitely not a gas. It's either got to be a liquid or a solid. Now when we look at boiling point, this is the point at which a liquid turns into a gas. Now for water, it boils at 100 degrees, hydrogen boils at negative 253, meaning that it's definitely going to be a gas because room temperature is a lot warmer than negative 253 degrees Celsius. Sodium chloride has a significantly larger boiling point compared to the rest of them. It will turn from a liquid into a gas at 1413 degrees Celsius. And then oxygen is a similar story to hydrogen again. It's a gas at room temperature. It will end up boiling from a liquid into a gas well below 0 degrees and certainly well below room temperature. Main thing to note though is that every single substance, an element or a compound has a different set of melting and boiling points and will mean that it is a solid, liquid or gas at different ranges of temperatures. Now we can start to look at density as well. Essentially density is if the amount of mass that is being shoved into a particular volume. So as an example here we have two different substances that have the same volume, but we can clearly see that here we have lots of particles packed in, meaning that there is more mass in the volume, meaning that it has a higher density than this guy over here, which doesn't have as many particles packed into the same volume. Now, this higher density means that it is, I guess, heavier than the low density block, but I guess we could also say that this block could have more mass if it was larger than the high density block as well. Now, this can lead to concepts such as buoyancy, whether things sink or float. The main idea here is things that are more dense than the other substance will end up sinking, and things that are less dense than the other substance would end up floating. So these sponges and wood blocks over here are less dense than water. There is less mass per volume. In these substances, so they end up floating. This metal here, whatever it is denser than water, so it ends up sinking. And a lot of the time, this density doesn't have a lot to do with how the particles are arranged or packed, but more by the mass of the particles themselves. So, as an example, if I packed 10 oxygen particles into the same volume as packing 10 iron particles into the same volume, the iron would be denser because each of those particles would end up being heavier than the oxygen itself. Now, there's a way to show this mathematically, and that's by using a density formula. This isn't one that shows up in your data sheet that you would get in an exam or in the HSC, but it may be one that you may have to use in a more challenging question. It doesn't happen particularly often. Now, what's important is that we measure density by dividing the mass of the substance by its volume. You can rearrange that equation to calculate for mass or volume if you knew the density of the substance already. Some additional resources. I do have this in C8 in our resource library. This is SI chemical data, and it shows all sorts of different properties. Properties that I've talked about today, and properties that we haven't seen at all yet. It's a book. It's got lots of tables. It's not a very nice read. It's very, very dense. It's more of a reference book, similar to a dictionary. You end up looking up properties of different kinds of chemicals when you need to, rather than, I guess, reading up on it and memorizing it from scratch. But certainly a very useful resource to be using at any point during the course. From here, we're going to be looking at a lot of those physical properties and applying them to be able to separate different kinds of mixtures. And you'll see that in the overview video that I'm about to do on separation techniques.